this is difficult to make curricular in this format, but with just a slight twist, we can put this into something called taxicab geometry. And in taxicab geometry, you're driving through a city. At each intersection, you can go north, east, west, or south only. And so here we have a loop in taxicab geometry. And this time we have to draw a square, and the vertices of the square this time have to actually be the intersections. And is this always possible? I do not know if this problem is equally tough to the other problem. Very few mathematicians have seen it. But I think that, first of all, this is much more curricular because you can deal with parallel, you can deal with perpendicular, you can deal with Cartesian. And kids adore this problem, creating their own loops and then trying to get other people to break their loops. So some kids go around and they are the breakers. They don't create a loop themselves, they just go around trying to break other people's solutions. So anyone want to come up and put a couple of squares on here?
Only on the vertices? But
only on the vertices, correct. Has to be on the vertices.
I can go.
Yeah, go for it. It's magic. Whenever you get close, it disappears. Just to make it tougher. Yeah, so here's one that is for sure a square. But you can also deal, stay up here and try to find one that isn't
aligned with the...
yeah, aligned with the orthogonal. Yeah, try to find one that isn't aligned orthogonally.
So hard.
Too much more. And you can, I mean, people can help. You don't have to be mute just because you're sitting in the audience.
The game show.
That's a square.
It's 2 over 2, 4 out.
And that's 4.
2 by 4.
So you have to do the square. Yeah. Okay. So this, I think, this is still unsolved for me. I don't know if this is possible to solve or not for all loops, no matter what taxicab loop you come up with. Is there always a square that you can find? What has been solved is given any loop not including a unit square, is it always possible to find at least 2 squares? Now that is a problem that can be solved by a grade 9, by grade 10 class. And the answer is no. But it's not easy to find. Nearly every loop that you look at will have at least 2 squares. So there's a lot of interesting unsolved problems to do with that. Like what percentage of loops? I have no idea. What percentage of loops have just 1 square? I think really interesting problem. Right. So there was your solution, the first one. Another one.